In this video, I would be talking about the detectors that are used in HPLC, that is high performance liquid chromatography. So depending on your target compounds, there could be 6 detectors that can be coupled with your high performance liquid chromatography to detect that particular compound. Now if the compound is having UV absorbing property, then the detectors that can be used is UV visible detectors, that is DAD, that is diode array detector, or PDA detectors. If your target compound has fluorescent emitting property, then the detector can be used as fluorescent detector. Now refractive index detectors are detectors that detect all compounds. It is a universal detector and it works on the principle of refraction of light. Now, evaporative light scattering detectors, that is also a universal detector which can detect all compounds but excluding volatile compounds. And conductivity detectors are detectors where in a sample there are cations and anions that has to be detected. So here conductivity detectors can be used. And mass spectroscopy detector, it detects the ionic compounds. When the sample, it is a destructive detector, that is the sample will be lost over here as the sample is ionized, and these ions are then detected using this mass spectroscopy. Now coming to your first detector, that is absorbance detector. It could be a DAD detector, it could be a PDA detector. Now absorbance detection is the most common detection in HPLC analysis. Now light is a type of electromagnetic wave, and these electromagnetic waves are given different names depending on the wavelength. Now in this picture you can see there is gamma rays, X-rays, UV rays, visible range, then infrared waves, microwaves and radio waves. Now this absorbance detection is based on the UV visible range. Now UV visible wavelength, it falls in the category of 200 to 800 nanometer. Now when a substance is irradiated with light, it absorbs light of a specific wavelength, and the energy of electrons change from their ground state to an excited state of energy. Now the wavelength of light absorbed depends on the structure of the substance that is present in that sample. Light in the UV to visible range is used in this kind of detectors, that is absorbance detector. Now in this figure, the principle of absorbance detection is used in HPLC analysis. The absorbance is measured by monitoring the rate of decrease in the amount of light that passes through the cell when irradiating the solution in the flow cell with light of a particular wavelength. Now the absorbance is proportional to the concentration of the target substance that is present in that sample. This can be defined as your Beer-Lambert's law. So in Beer-Lambert's law, what happens is there's a flow cell and there is your sample present. Okay, the analyte is present, and when the light is put on that flow cell, the analyte, whatever analyte is present in that flow cell, it will absorb that particular wavelength, and then the light that is transmitted would be different than it was before. So this absorbance is directly proportional to the concentration of analyte that is present in the flow cell. Now in this diagram you can see a UV detector and a PDA detector. Now coming on to the UV detector, a deuterium lamp is used as an ultraviolet light source for UV detector. The light emitted from the lamp is separated into a light beam of a certain wavelength with a diffraction grating, and then it passes to the flow cell. The light that passes through the flow, it enters this photodetector, that is called photodiode, and is converted into an electrical signal corresponding to the intensity of light, which is then processed as absorbance. Now a UV visible detector with a deuterium lamp and a tungsten lamp is suitable for monitoring only UV, not only UV light but also visible light. Now in the other figure, the PDA detector, the light is emitted from a lamp installed in the PDA detector that passes through the flow cell and then separated with a diffraction grating. Now when the separated light beam is received by a photodiode, which is a sequence of 1024 photodetectors, only the wavelength in the specified range are converted into electrical signals and processed as absorbance data. In some cases, it is also called as a DAD detector, that is diode array detector. Using a PDA detector allows you to measure a continuous UV spectrum, resulting in multi-wavelength chromatogram. The detector not only provides you a chromatogram that refers to y-axis and x-axis, but it will also allow you for a three-dimensional data having a wavelength axis on the z-axis. So as you can see in this diagram, there's not only x-axis that gives you the time range, but there's also y-axis that tells us about the intensity of the peak, and there can be different wavelengths where you can detect the peaks. So there it is a multi-wavelength detector. Now as you can see here on the screen, this is a graph where 310 and 355 wavelength has been used, and you can see there are three peaks that are obtained: peak A, peak B and peak C. Okay, this is a PDA detector which allows you to detect three peaks at a time, that is peak A, peak B and peak C. Now in this spectrum, this is the identification of peak B when it is detected at a wavelength of 310 nanometer. While in PDA detectors, you all could see that three peaks could be detected, peak A, B and C, because multi-wavelength analysis can be done over there. Now coming on to your fluorescent detector, when a compound is irradiated with light, electrons in the energetically stable ground state use the energy of light to transition to energetically high and unstable excited state. Now these molecules that transition to the excited state lose energy continuously due to heat or collision with other molecules and return to the ground state. Now this is the normal process. When it is excited, it from ground level it will go to the excited level, and as and when the energy is released, it will come to the ground state again. This emission is called photoluminescence and include fluorescence and phosphorescence. This is the principle of fluorescence emission. Now the absorbance detection is based on the absorption that occurs when a compound irradiated with light transition from the ground state to the excited state. Fluorescence detection is a detection method that uses fluorescence emitted when a compound returns to the ground state and transitioning to the excited state. Compounds containing functional groups with absorption bands can be detected by an absorbance detector, and only compound with fluorescent property can be detected by a fluorescence detector. Now in this diagram you can see a fluorescence detector. There's a xenon lamp that is generally used for a light source of a fluorescence detector. The light that is emitted from the lamp is separated into a light beam of certain wavelength with the excitation grating and then passes to the flow cell. Now when there is a substance in the flow cell that receives a specific wavelength of light and transition to an excited state, it becomes a fluorescent compound. Now the light emitted from the compound is split by the emission grating and is converted into an electrical signal according to its intensity by a photomultiplier. And whatever data is generated by the detector, it is sent to your data processor. Now the advantage of using a fluorescence detector is that it can be detected by excitation and fluorescence wavelength specific to a particular substance, which leads to a higher selectivity of detection as compared to the other detectors. Furthermore, the analysis results would not be affected by noise derived from the mobile phase because the detector is not capable of detecting any non-fluorescent compounds here. Only the fluorescent emitting compounds are detected. So the mobile phase, whatever noise is generated by the mobile phase, it cannot be detected. Therefore, the signal to noise ratio is higher as compared to the UV detector. Now in this diagram you all can see there is a isopropyl methyl phenol compound. Now it can be detected in UV detector as well as fluorescent detector, but you all can see the intensity of the peak is very less in UV detector. The intensity is very less. The signal to noise ratio is only 317 as compared to the fluorescent detector where the signal to noise ratio is almost 10 times higher, more than 10 times higher. So this is the baseline. This is called as baseline and this is your signal. So the signal to noise ratio is very high if that compound that is present in your sample has fluorescent emitting property, then fluorescent detector can be used and the signal to noise ratio would be very high as compared to the UV detector. Now coming to refractive index detector. Now as I've told you all, this is a universal detector. All compounds can be detected through RI detectors. Now when a light beam or rays that transmit a substance refract at the boundaries of different substances, such as when it travels from gas through liquid, the beam of light will refract. Now this refractive index detectors is detection method that applies the principle of light refraction. Now in this diagram you all can see that the light is emitted from the lamp. It passes through the slit and transmit the flow cell as a parallel beam. The transmitted light from the flow cell forms a slit image of the photodiode. The sample side is called the sample cellular, through which the mobile phase containing the analyte passes continuously. It is a continuous process. Now coming to the reference side, This is called as reference cell and it is filled with only mobile phase. Now, when only the mobile phase flows on the sample side, the light ray travels straight without any refraction, because both in the this reference cell and sample cell, it is the same mobile phase. There is no analyte present. But when there is a change in mobile phase, when there is analyte present in the sample cell, there is refraction happening. And this change in the light scattering, it is recorded and then it is sent to the data processor. Now, as you all know that RI detectors are universal detectors because it can detect all compounds that show any refractive index from that of the mobile phase in principle. Now this method, it requires sufficient column separation because of the poor selectivity and sensitivity of the compounds that can be detected. Furthermore, it is easily affected by the fluctuation of any kind of temperature change or pressure change in the surrounding. The RID detector shows small sensitivity difference depending on the target compounds. Now this feature affords rough abundance proportion of sample components so that the RID is commonly used in GPC analysis for calculating the molecular weight distribution. Now as you can see in this picture, A is a graph where 100% concentrated orange juice is used and B is orange soft drink. So you all can see in picture A, the peak of sucrose is higher compared to the orange soft drink content, where the peak of fructose is higher in second image. Now coming to evaporative light scattering detector, ELSD detectors. They are aerosol based HPLC detector which work by converting the elements of target compounds to a fine spray via a nebulizer. So when the sample is eluted from the column, it is in the form of liquid. But because of the nebulization that happens, it is converted into aerosol. And here, for conversion of that liquid to aerosol, nitrogen gas is used. This spray is then heated so that only mobile phase evaporates. Now light is then focused on the remaining target substance and scattered light is detected. Now the primary advantage of researchers using ELSD is that unlike spectroscopic detectors, it can identify samples which cannot be found using UV detection methods such as carbohydrate, sugar, alcohol, surfactants and natural synthetic molecules. Now coming to your conductivity detector, it is a kind of detector which is where electric conductivity measurement of solution is a method of detecting ions in a solution. Now after the target ions are eluted, the change in the electric current is detected here with a constant voltage imposed between the electrodes. Now a conductivity detector is employed as a detector in this ion chromatograph, which is a system dedicated to measuring the ions present in the sample. This detector is used mainly to measure inorganic ions and small organic substances including organic acids and amines. Now, negative ions that can be measured here is fluorine, chlorine, bromine, and positive ions that can be detected are sodium, potassium, magnesium, and calcium. The conductivity detector is highly sensitive but very susceptible to the effect of temperature variation. Now, various methods of avoiding temperature variation has been devised, such as constant temperature cells. Now this detectors is mostly used for water analysis, where you have to where you have to do the analysis of uh, the water containing certain chlorine, bromine, or the content of magnesium or calcium in a water. Now coming to mass spectroscopy, now this is the most widely used detector in HPLC. It is coupled with HPLC. Now, these spectrometer, it detects, identifies and quantifies molecule within sample based on the molecular mass to charge ratio after ionization. Here also the sample is destructed, that is, it is ionized, and that ions, it goes through Q1 quadrupole and then Q2 quadrupole, where it is again it is bombarded with high voltage and their daughter ions are produced, and then it goes to the Q3 quadrupole and then daughter ions are detected. So in this type of detector, what happens, you get a double confirmation that whatever analyte has been detected in Q1, that only analyte we are actually looking for in a substance. So this type of detector, it is on the principle of mass to charge ratio, and it gives you double confirmation. Now this was all about the HPLC detectors that can be used.